Hello, and welcome to the Slumber Lab. I'm so glad you found your way here tonight. Whether you're already nestled under your covers, letting the weight of the day slowly dissolve, or simply letting your mind drift toward that gentle edge between waking and dreaming, this space was made for you. Tonight, we're going to embark on a journey that feels both impossibly vast and intimately quiet. We're going to explore one of the universe's most fundamental rules, a cosmic speed limit that governs everything from the tiniest particles to the grandest galaxies. And we're going to discover that this limit isn't just about light, though light plays the starring role in our story. But before we drift into the depths of space-time and relativity, take a moment to settle in. Maybe adjust your pillow, pull that blanket a little closer, let your breathing slow and deepen. Because what we're about to explore together is both profound and peaceful, complex, yet strangely comforting. The universe, it turns out, has built-in boundaries that create order from chaos, meaning from motion. You might think of speed limits as human inventions, those yellow signs on highways that keep traffic flowing safely. But long before humans walked the earth, long before we invented cars or roads, or even the concept of velocity, the universe had already established its own ultimate speed limit. Not 65 miles per hour, not even 65,000 miles per hour, but something far more absolute, far more elegant, and far more mysterious. This cosmic speed limit is roughly 186,282 miles per second, or about 299,792,458 meters per second if you prefer the metric system. You know this number, even if you've never memorized it. It's the speed of light. But here's where our journey begins to get interesting, where the obvious becomes wondrous. This isn't just the speed at which light travels, it's the speed at which reality itself unfolds. It's the maximum rate at which cause can become effect, at which information can flow from one point in space to another, at which the universe allows anything to happen. Think about that for a moment as you lie there in the gentle darkness. Every photon of light that has ever touched your skin, every signal that has ever reached your eyes, every electromagnetic wave that has ever carried a radio song or a phone call, all of them respect this same fundamental limit. But so does everything else. Gravity waves, the ripples in space-time itself, travel at this speed. The strong nuclear force that holds atomic nuclei together operates within this constraint. Even the expansion of space itself, in the earliest moments after the Big Bang, was governed by this same cosmic law. But why does this limit exist at all? What would happen if it didn't? And perhaps most intriguingly, what does it mean for the very nature of time, space, and existence itself? These questions have puzzled physicists for over a century, and tonight, in the quiet sanctuary of your bedtime thoughts, we're going to explore them together. You see, this speed limit isn't arbitrary. It's not like someone flipped a cosmic coin and decided that 82 miles per second sounded about right. Instead, it emerges from the very structure of reality, from the way space and time are woven together into what Einstein called spacetime. This limit is built into the universe at the most fundamental level, like the rules of a game that was being played long before anyone was around to understand the rulebook. And here's something that might surprise you. While we call it the speed of light, light itself isn't special in any cosmic sense. Photons, the particles of light, travel at this speed not because they're magical or privileged, but because they have no mass. Any particle with zero mass must travel at this speed, and any particle with mass cannot. It's that simple and that profound. This brings us to one of the most beautiful and counterintuitive aspects of our cosmic speed limit. From our everyday perspective, it seems like the faster you're already moving, the easier it should be to go a little faster. If you're walking, you can break into a run. If you're running, you can sprint. If you're driving, you can press harder on the accelerator. The pattern seems clear. Add more energy, go faster, but the universe has other plans. As objects with mass approach this cosmic speed limit, something extraordinary happens. The faster they go, the more energy it takes to go even faster. And not just a little more energy, exponentially more energy. By the time you're traveling at 90% the speed of light, it takes enormous amounts of energy to gain even a tiny bit more speed. At 99%, the energy required becomes astronomical. At 99.9%, it becomes practically infinite. This isn't a limitation of our technology or our understanding. It's a fundamental feature of reality itself. The universe simply will not allow anything with mass to reach, let alone exceed, this speed. It's as if the cosmos has a gentle but absolutely firm hand that says this far and no further. But this cosmic speed limit does more than just constrain motion. It defines the very nature of simultaneity, of what we mean when we say now. In our everyday experience, now seems universal. When you look at the clock and see that it's midnight, it feels like it's midnight everywhere, like there's a single, universal present moment shared by the entire universe. The reality is far stranger and more beautiful. Because of this speed limit, because information cannot travel faster than light, there is no universal now. Events that seem simultaneous to you might occur at different times for someone moving relative to you. The present moment, that thing that feels so solid and immediate as you lie in bed listening to these words, is actually more like a gentle bubble of experience, bounded by the speed at which information can reach you. This means that the universe is not like a vast clockwork mechanism, with all its parts synchronized to some cosmic timekeeper. Instead, it's more like a symphony, with different sections playing their parts in a harmony that emerges from the fundamental constraints of space-time itself. The speed limit doesn't create chaos, it creates coherence. It ensures that cause precedes effect, that stories have beginnings, middles, and ends, that the universe makes sense in a deep and beautiful way. Consider for a moment the light that's reaching your eyes right now, whether from a bedside lamp, the glow of a screen, or perhaps just the faint luminescence of electronics in standby mode. Every photon in that light began its journey at the moment of its creation, traveling at exactly the cosmic speed limit, and it will continue at that speed until it encounters something, an atom in your retina, a molecule in the air, the surface of a wall. It cannot go faster, it cannot go slower, and it cannot rest. This consistency, this absolute reliability of the cosmic speed limit, is what makes the universe predictable and beautiful. It's what allows atoms to hold together, stars to shine steadily for billions of years, and galaxies to maintain their majestic spiral arms across cosmic time. Without this limit, the universe would be a chaotic place where effects could precede causes, where the arrow of time could point in any direction, where the very concept of causality would break down. But perhaps most remarkably, this speed limit connects everything in the universe in a profound way. Because information, influence, and causation all respect this same boundary. Everything in the cosmos exists within overlapping spheres of possible connection. The light from distant stars, traveling for millions or billions of years at this cosmic speed limit, carries information about the deep past directly to your eyes in the present moment. When you look up at the night sky, you're not just seeing distant objects. You're seeing the universe's history, layer upon layer of light that has been traveling toward you for different amounts of time, all of it moving at the same fundamental speed, all of it carrying stories from different chapters of cosmic time. The star you see might have died millions of years ago, but its light, traveling faithfully at the cosmic speed limit, only reaches you now, in this quiet moment as you prepare for sleep. This cosmic speed limit also means that the universe has a kind of built-in patience. Nothing can happen instantly across large distances. If the sun were to suddenly disappear, we wouldn't know it for about 8 minutes, the time it takes light to travel from the sun to Earth. If the nearest star to our solar system were to explode in a brilliant supernova, we wouldn't see it for over 4 years. The universe enforces a kind of cosmic courtesy, giving us time to process, to respond, to exist within our local sphere of influence before being affected by distant events. And this brings us to one of the most profound implications of the cosmic speed limit. It doesn't just govern how fast things can move through space, it governs how fast time itself can unfold. Time and space are not separate things that happen to be related. They are aspects of a single unified fabric called spacetime, and this fabric has its own built-in maximum rate of change. This is why we can say that the cosmic speed limit isn't really about light at all. Light simply happens to be the most familiar thing that travels at this speed, but the speed itself is more fundamental. It's the speed at which time and space relate to each other, the speed at which the universe allows reality to propagate from one point to another. As you settle deeper into your pillow tonight, as your breathing slows and your thoughts begin to drift towards sleep, you're experiencing time at its most natural pace. Your neurons are firing, your heart is beating, your cells are carrying out their quiet work of maintenance and repair, all of it happening within the gentle constraints of the cosmic speed limit. The electrical signals in your nervous system travel much slower than light, but they still respect the fundamental boundary that governs all of reality. In a sense, you are part of this cosmic symphony, this vast, interconnected web of causation and information that spans the universe. Every thought you think, every breath you take, every moment of rest and restoration happens within the same framework that governs the motion of galaxies, the dance of subatomic particles, and the propagation of light from the most distant quasars. The cosmic speed limit isn't a constraint that limits the universe's potential. It's a foundation that makes the universe's complexity and beauty possible. Without it, there would be no stable structures, no persistent patterns, no reliable relationships between cause and effect. There would be no stars, no planets, no life, no consciousness, no quiet moments like this one where we can contemplate the deep structures of reality. But our exploration of this cosmic speed limit has only just begun. We've touched on its existence, its universality, and some of its most basic implications. But there are deeper mysteries waiting for us, stranger consequences that emerge when we really think through what it means for the universe to have this fundamental constraint. What happens when objects approach this speed limit? How does the universe enforce this boundary, and what strange effects emerge as a result? Why do time and space themselves seem to change when viewed from different perspectives? And perhaps most intriguingly, what does this speed limit tell us about the very nature of reality, about what the universe is made of at its deepest level? These questions will guide us deeper into our gentle exploration of cosmic mysteries. As we continue our journey together, we'll discover that this speed limit is just the beginning of a story that connects the smallest scales of quantum mechanics to the largest scales of cosmology. A story that reveals the universe to be far stranger, far more beautiful, and far more elegantly constructed than our everyday experience might suggest. For now, though, as this first part of our exploration draws to a close, let yourself rest in the quiet wonder of knowing that you exist within a universe governed by such elegant and profound laws. The same cosmic speed limit that governs the light from distant galaxies also governs the gentle electrical activity in your brain as you process these thoughts, as you drift toward the peaceful realm of sleep. The speed limit we've been exploring together has a curious property that becomes apparent when we start to examine what happens as objects approach it. In our everyday world, speed is additive in the way you might expect. If you're walking forward on a moving train, your speed relative to the ground is your walking speed plus the train's speed. simple arithmetic. But as we venture closer to the cosmic speed limit, this comfortable arithmetic begins to break down in the most beautiful and mysterious ways. Let me paint you a picture as you rest there in the gentle darkness. Imagine a spacecraft accelerating through the void, its engines burning bright against the star-filled blackness. From our perspective, watching from Earth, the ship grows faster and faster, but something strange happens as it approaches significant fractions of the cosmic speed limit. The energy required to gain each additional mile per second becomes enormous, as if the universe itself were gradually but firmly applying the brakes. This isn't because space becomes thicker or more resistant, like trying to move through honey instead of air. Space remains the same perfect vacuum it has always been. Instead, something far more fundamental is happening. The very relationship between energy and motion begins to change. Mass itself, that most basic property of matter, begins to behave differently. You see, mass isn't quite what we thought it was in our everyday experience. When we hold an object, when we feel its weight in our hands, we're experiencing what physicists call rest mass, the mass an object has when it's sitting still relative to us. But mass has a secret. It's not constant. As objects approach the cosmic speed limit, they become more massive, not by gaining more matter, but by gaining what we might call relativistic mass, a kind of mass that emerges from motion itself. This increasing mass is what creates the cosmic speed limit's enforcement mechanism. The faster an object moves, the more massive it becomes. The more massive it becomes, the more energy is required to accelerate it further. By the time an object with any rest mass at all reaches 99% of the cosmic speed limit, its relativistic mass has become so enormous that reaching 100% would require infinite energy. And infinite energy, the universe gently reminds us, is not available. But here's where our bedtime story takes an even more wondrous turn. This effect isn't just theoretical, it's happening all around us right now, in ways both subtle and profound. In particle accelerators around the world, scientists routinely accelerate tiny particles to within fractions of a percent of the cosmic speed limit. These particles, electrons and protons, no bigger than points, become thousands of times more massive than they are at rest. Their behavior confirms again and again that this speed limit is not merely a suggestion, but a fundamental law woven into the fabric of reality. The particles themselves experience something even stranger. From their perspective, racing through the accelerator at nearly the cosmic speed limit, time itself behaves differently. What we observe as hours of acceleration, they experience as mere moments. Their internal clocks, if they had such things, would tick more slowly relative to ours. This isn't science fiction. It's a measured, predictable consequence of approaching the universal speed limit. This brings us to one of the most profound and beautiful aspects of our cosmic speed limit. It doesn't just govern motion through space, it governs the very flow of time itself. Time, that most personal and immediate aspect of our experience, the rhythm by which we measure our heartbeats and our breaths as we settle into sleep, is not as universal as it seems. Picture two observers, perhaps twins for the sake of our gentle thought experiment. One remains on Earth, living a normal life, aging day by day, year by year. The other embarks on a journey in a spacecraft capable of traveling at 90% of the cosmic speed limit. From Earth's perspective, both twins continue to age, but the traveling twin ages more slowly, not because of any exotic technology or magical intervention, but simply because time itself flows more slowly for objects moving at high speeds relative to other objects. This isn't a metaphor or an approximation. It's a literal description of how the universe works. Time dilation, as physicists call this effect, has been measured with atomic clocks on airplanes, observed in the behavior of particles from cosmic rays, and must be accounted for in the GPS satellites that help us navigate our daily lives. The universe's speed limit doesn't just constrain motion, it reveals that time itself is far more flexible and relative than our intuition suggests. But the strangeness doesn't end with time. Space itself, that vast emptiness between stars and planets, that seemingly unchanging backdrop against which all motion occurs, is also subject to the cosmic speed limit's influence. As objects approach this fundamental velocity, space itself appears to contract in the direction of their motion. From the perspective of our nearly light-speed traveler, distances in the direction of travel become compressed as if the universe were gently folding space to accommodate the constraints of the speed limit. This length contraction isn't an optical illusion or a measurement error. It's a fundamental feature of how space and time relate to each other at high velocities. The universe, it seems, will bend both time and space before it will allow anything with mass to exceed the cosmic speed limit. It's as if reality itself has a kind of built-in flexibility, a willingness to transform rather than break its most fundamental rules. These effects, time dilation and length contraction, might seem exotic and removed from our everyday experience as we lie here in the quiet comfort of our beds. But they reveal something profound about the nature of reality itself. Space and time are not the fixed, absolute backdrops that they appear to be in our daily lives. They are dynamic, interconnected aspects of a single entity that Einstein called spacetime. And this entity responds to motion in ways that preserve the cosmic speed limit above all else. The preservation of this speed limit is so fundamental to the universe's operation that everything else, even our most basic concepts of distance and duration, must yield to maintain it. This suggests that the cosmic speed limit isn't just another physical law like gravity or electromagnetism. It's something deeper, something that defines the very stage upon which all other physical laws perform their cosmic dance. As you breathe slowly and steadily, as your body settles into the rhythm of approaching sleep, you're experiencing time and space in their most natural, comfortable form. The effects we've been discussing become noticeable only at velocities that dwarf anything in human experience. But they're always there, lurking beneath the surface of reality, ready to emerge whenever motion approaches the cosmic boundary. This raises a fascinating question. Why should the universe be constructed this way? Why should there be a speed limit at all? And why should it have the particular value that it does? These aren't questions with simple answers, but they point towards something even more fundamental about the nature of reality. The cosmic speed limit appears to be one of what physicists call the fundamental constants of nature. These are numbers that seem to be built into the universe at the most basic level. Numbers that determine how strong gravity is, how electric charges interact, how atoms hold together, and yes, how fast information and causation can propagate through space and time. If any of these constants were significantly different, the universe as we know it simply couldn't exist. Stars wouldn't form or would burn out too quickly. Atoms wouldn't be stable. The delicate balance that allows complexity and life to emerge would be impossible. The cosmic speed limit, it seems, isn't just any old speed. It's exactly the speed that allows our universe to be both stable and interesting, both predictable and surprising. But there's another layer to this mystery, one that touches on the very deepest questions about the nature of existence. The cosmic speed limit doesn't just govern how fast things can move. It governs how fast information can travel, how quickly cause and effect can unfold, how rapidly the future can emerge from the present. In essence, the cosmic speed limit is the speed at which reality itself updates. It's the maximum rate at which the universe can process change, can compute the next moment from the current one, can weave the threads of causation into the tapestry of existence. This makes it sound almost like the universe is a vast computer, operating at a maximum processing speed determined by fundamental physical laws. This perspective opens up profound questions about the nature of reality itself. Is the universe in some sense computational? Are the laws of physics something like algorithms, running on the substrate of space-time itself? And if so, what does that tell us about our place in this cosmic information processing system? These questions push us to the very edge of current scientific understanding, into realms where physics begins to touch on philosophy, where the study of matter and energy begins to merge with the study of information and computation. As you drift towards sleep, as your consciousness prepares to slip into the different kind of information processing we call dreams, you're participating in one of the universe's most remarkable phenomena, the emergence of awareness from the complex dance of particles and forces, all operating within the constraints of the cosmic speed limit. But our exploration of this fundamental boundary has revealed something even more beautiful and mysterious. The cosmic speed limit isn't just about limits and constraints, it's about connections and relationships. It defines how different parts of the universe can influence each other, how information can flow from one region to another, how the past can shape the future, and the future can emerge from the present. Every photon of light that has ever reached your eyes, every radio wave that has ever carried a song to your ears, every gravitational wave that has ever rippled through the fabric of space-time itself, all of them have respected this same fundamental boundary. They've all carried information at exactly the cosmic speed limit, no faster and no slower, weaving together the threads of causation that connect every part of the universe to every other part. This creates a kind of cosmic web of connectivity, a network of potential influence that spans the entire observable universe. Everything that can affect you, everything that can send you information or energy or gravitational influence, lies within a sphere whose radius is determined by the cosmic speed limit and the age of the universe. Beyond that sphere, there are regions of space and time that are still causally disconnected from you, places that cannot yet influence your life or your world. But this sphere is constantly expanding at exactly the cosmic speed limit, bringing new regions of the universe into causal contact with us, allowing new information and new influences to reach us for the first time. In a very real sense, the observable universe is growing larger every moment, not because space is expanding, though it is, but because light and information from more distant regions are finally having enough time to reach us. This gives the cosmic speed limit an almost gentle, patient quality. It doesn't cut us off from the rest of the universe. It simply ensures that we encounter it gradually, in a measured way that preserves causality and meaning. It's as if the universe has a built-in kindness, revealing itself to us bit by bit, moment by moment, at exactly the pace that allows us to make sense of what we're experiencing. As we prepare to venture even deeper into these cosmic mysteries, as we ready ourselves to explore the even stranger implications of the universe's fundamental speed limit, let yourself rest in the knowledge that you are part of this vast, interconnected web of causation and information. The same laws that govern the motion of distant galaxies also govern the electrical signals in your nervous system as you process these thoughts, as your brain prepares for the different kind of information processing that occurs during sleep. The cosmic speed limit isn't just an abstract physical law. It's part of the very foundation that makes your existence possible, that allows the complex chemistry of life to unfold in stable, predictable ways, that ensures the universe has the kind of ordered structure necessary for consciousness to emerge and contemplate its own cosmic context. But we've only begun to scratch the surface of what this fundamental boundary reveals about the nature of reality. There are deeper mysteries waiting for us, stranger consequences that emerge when we truly think through what it means for the universe to have this ultimate speed limit. Questions about the nature of simultaneity, about the relationship between energy and matter, about the very fabric of space and time itself. These deeper mysteries begin to reveal themselves when we consider what happens at the very moment something reaches the cosmic speed limit. We've talked about how particles with mass can approach but never quite achieve this velocity, how they become more and more massive as they accelerate, requiring ever-increasing amounts of energy to go just a little bit faster. But what about the things that do travel at this cosmic boundary? What about light itself and the other massless particles that share its perfect velocity? Here we encounter one of the most beautiful paradoxes in all of physics. From our perspective, watching a beam of light travel from a distant star to our eyes, that journey takes time. Years, centuries, millennia, depending on the distance. We can measure how long the light has been traveling, calculate when it began its journey, imagine it crossing the vast emptiness of space at exactly the cosmic speed limit. But from the photon's perspective, if we could somehow experience the universe from the point of view of a particle of light, something extraordinary happens. The journey takes no time at all. Zero. Not a brief moment, not an instant, but literally no time. From the moment of its creation to the moment of its absorption, from its birth in the nuclear furnace of a star to its death in the retina of your eye, the photon experiences no passage of time whatsoever. This isn't just a quirky mathematical result. It's a profound statement about the nature of existence at the cosmic speed limit. For anything traveling at this fundamental velocity, time simply stops. Distance becomes meaningless. The entire universe, from one edge of the observable cosmos to the other, becomes a single point in space and time. Think about this as you lie there in the gentle darkness. Every ray of starlight touching your skin right now, every photon that has traveled for millions of years to reach you, experienced its entire journey as a single timeless moment. The light from the most distant galaxies, light that began its voyage when the universe was young and stars were just beginning to form, that light exists in a state where past, present, and future collapse into a single eternal now. This gives us a glimpse into something truly profound about the cosmic speed limit. It's not just a maximum velocity. It's a boundary between two completely different ways of experiencing reality. Below this speed, time flows, distance matters, cause and effect unfold in sequence. At this speed, all of that disappears into a timeless, spaceless unity. But this raises an even deeper question about the nature of information and causation in our universe. We've established that nothing can travel faster than the cosmic speed limit, that this boundary is absolute and inviolable. But what does this mean for the flow of information itself? What does it mean for the very concept of now across the vast reaches of space? In our everyday experience, simultaneity seems obvious. When you look at your clock and see that it's exactly midnight, it feels natural to think that it's midnight everywhere, that there's a universal present moment shared by the entire cosmos. But the cosmic speed limit reveals this intuition to be beautifully wrong. Because information cannot travel faster than light. Because no signal can exceed the cosmic velocity. There is no way to define a universal now that applies everywhere in the universe simultaneously. The present moment, that intimate experience you're having right now as you listen to these words, as your thoughts drift and your breathing slows, is actually a local phenomenon, bounded by the sphere of space from which light has had time to reach you. This creates what physicists call the relativity of simultaneity. Events that appear to happen at the same time from your perspective might occur at different moments for someone moving relative to you. The faster that relative motion, the greater the difference in timing. At velocities approaching the cosmic speed limit, this effect becomes so pronounced that events you perceive as simultaneous might be separated by hours, days, or even years from another observer's perspective. This doesn't mean that one perspective is right and another is wrong. Both are equally valid descriptions of reality. Instead, it reveals that simultaneity itself is not a fundamental feature of the universe, but rather a consequence of how we, as observers moving at particular velocities, sample the information that reaches us at the cosmic speed limit. This relativity of simultaneity has profound implications for our understanding of causation and free will. If there's no universal now, if different observers can disagree about the timing of events, what does this mean for the sequence of cause and effect? How can we say that one event causes another if different observers might disagree about which happened first? The answer lies in the cosmic speed limit itself. While observers might disagree about the timing of distant events, they will always agree about the causal relationships between events that can actually influence each other. If event A can cause event B, if information or energy or influence can flow from A to B, then all observers will agree that A happened before B, regardless of their relative motion. The cosmic speed limit, in other words, preserves causality even as it allows simultaneity to become relative. It ensures that causes always precede their effects, that the arrow of time points consistently forward, that the universe maintains a coherent narrative structure even when viewed from different perspectives. This protection of causality is perhaps the most important function of the cosmic speed limit. Without it, we could have a universe where effects preceded their causes, where messages could arrive before they were sent, where the very notion of logical sequence would break down. The cosmic speed limit doesn't just govern motion, it governs meaning itself, ensuring that the universe remains comprehensible, that stories can have beginnings, middles, and ends. But the cosmic speed limit reveals another layer of strangeness when we consider the nature of space itself. We tend to think of space as empty, as nothing more than the stage upon which the drama of physics unfolds. But the cosmic speed limit suggests that space is far more active and fundamental than this simple picture would suggest. You see, the cosmic speed limit is built into the very geometry of space-time. It's not imposed from outside like a traffic law. It emerges from the mathematical structure of reality itself. Space and time are not separate entities that happen to be related. They are aspects of a single, unified fabric whose geometry naturally gives rise to this fundamental velocity. This geometric interpretation helps explain why the cosmic speed limit is so absolute. It's not that there's some cosmic enforcement mechanism preventing faster than light travel. It's that faster than light is a concept that doesn't make sense within the geometry of space-time, like asking what's north of the North Pole, or what happened before the beginning of time. The cosmic speed limit, in this view, is simply a reflection of how distances and durations relate to each other in the four-dimensional fabric of space-time. Just as a circle's circumference is always related to its radius by the constant p, the relationship between space and time is mediated by the cosmic speed limit, that fundamental constant that determines how much space corresponds to how much time. This geometric understanding also helps explain why massive objects cannot reach the cosmic speed limit. As we add energy to accelerate an object, we're not just making it move faster through space, we're changing its trajectory through space-time itself. The more energy we add, the more the object's path through space-time curves toward the light-like geodesics that massless particles follow. But for any object with mass, no matter how much energy we add, its path through space-time always remains slightly tilted away from these light-like geodesics. It's as if massive objects are geometrically prevented from achieving the cosmic speed limit by the very structure of the space-time they move through. This geometric perspective also reveals why time dilation and length contraction occur near the cosmic speed limit. These aren't mechanical effects, like parts of a machine stretching or compressing under stress. They're geometric effects, consequences of how different observers sample the four-dimensional structure of space-time. When you observe an object moving at high speed relative to you, you're not seeing the object change shape or slow down in some absolute sense. You're seeing how the object's four-dimensional trajectory through space-time appears when projected onto your particular three-dimensional slice of the present moment. Different observers, moving at different velocities, project space-time onto different three-dimensional slices, which is why they measure different lengths and different rates of time flow. This might sound abstract as you lie there in the comfort of your bed, but it points toward a profound truth about the nature of reality. The familiar three-dimensional world of length, width, and height, the world that seems so solid and immediate in your daily experience, is actually just a cross-section of a richer, four-dimensional reality. Time isn't something that happens to this three-dimensional world. It's another dimension, as real and fundamental as the spatial dimensions, woven together with them into the unified fabric of space-time. The cosmic speed limit is the mathematical constant that determines how this weaving works, how space and time relate to each other, how the four-dimensional fabric of space-time maintains its structure and coherence. It's the speed at which the universe updates itself, the rate at which the future emerges from the present, the velocity at which reality itself propagates from one event to the next. But perhaps the most remarkable aspect of the cosmic speed limit is how it connects the largest and smallest scales of reality. The same fundamental velocity that governs the motion of galaxies also governs the behavior of subatomic particles. The same constant that determines how light travels between stars also determines how electric and magnetic fields propagate through the quantum vacuum. This universality suggests that the cosmic speed limit is truly fundamental, not just another physical law, but something more basic, something that defines the very framework within which all other physical laws operate. It's as if the universe has a built-in clock speed, a fundamental rate at which it can process information and compute the next moment from the current one. This computational metaphor becomes even more intriguing when we consider the role of information in modern physics. Increasingly, physicists are discovering that information, not matter or energy, might be the most fundamental constituent of reality. The cosmic speed limit in this view becomes the maximum rate at which information can be processed, the ultimate bandwidth of the universe itself. Every interaction between particles, every measurement, every quantum mechanical collapse of a wave function, all of these fundamental processes respect the cosmic speed limit. Information can flow from one part of the universe to another no faster than light can travel. This creates a kind of cosmic internet, a network of information exchange that connects every part of reality to every other part, but with a fundamental speed limit that ensures the network remains stable and causal. As you drift deeper towards sleep, as your conscious mind begins to release its grip on the details of waking life, you're participating in your own information processing system that operates well within the constraints of the cosmic speed limit. The electrical signals in your brain, the chemical communications between your neurons, the complex dance of consciousness itself, all of it unfolds at speeds far below the fundamental boundary we've been exploring. Yet in a deeper sense, you're intimately connected to this cosmic information network. Every photon that reaches your eyes, every electromagnetic wave that your brain generates and responds to, every quantum interaction in the molecular machinery of your cells, all of it operates within the framework defined by the cosmic speed limit. This isn't just poetic metaphor. It's a literal description of your place in the universe's information processing system. You are not separate from the cosmos. You are a local concentration of information processing, a temporary eddy in the vast flow of causation and communication that connects every part of reality to every other part. The cosmic speed limit ensures that this vast network remains coherent, that information flows in an orderly fashion, that the future emerges from the present in a way that preserves meaning and causality. Without this fundamental boundary, the universe would be a chaotic place where anything could influence anything else instantaneously, where the very notion of sequence and story would break down. Instead, we live in a universe where information flows at exactly the right speed to allow complexity to emerge, to allow stable structures to form, to allow consciousness to arise and contemplate its own cosmic context. The cosmic speed limit isn't a limitation on the universe's potential. It's the foundation that makes the universe's beauty and complexity possible. But there's something even more mysterious waiting for us as we venture deeper into the implications of this cosmic boundary, something that reveals just how profoundly the speed limit shapes not just motion, but the very fabric of existence itself. You see, this fundamental velocity doesn't just govern how fast things can move through space. It governs how space and time themselves can respond to the presence of matter and energy. Consider the gentle pull you feel right now, the soft pressure of your body against your mattress, the way gravity holds you close to the Earth's surface. This familiar force, so constant and reliable that we barely notice it, is actually information traveling at the cosmic speed limit. Gravity, Einstein discovered, isn't really a force at all. It's the curvature of space-time itself, and changes in this curvature propagate outward at exactly the speed we've been exploring together. Imagine, in the quiet theater of your mind, what would happen if the sun suddenly vanished. Not in some gradual fade, but simply disappeared in an instant, as if someone had turned off a cosmic light switch. How long would it take for Earth to feel the change? Our intuition might suggest that we'd immediately fly off into space, no longer held in our familiar orbit. But the cosmic speed limit has other plans. For precisely 8 minutes and 20 seconds, we would continue orbiting exactly as we always have, even though the sun no longer exists. The gravitational information, the news that our star has disappeared, can travel no faster than light itself. The fabric of space-time around Earth would continue curving in the sun's absence, like ripples on a pond that keep moving long after the stone that created them has sunk to the bottom. Only when that information finally reaches us, traveling at the cosmic speed limit across the 93 million miles of space between Earth and Sun, would we suddenly find ourselves flying free through the darkness. The last photons of sunlight and the last gravitational influence would arrive together at exactly the same moment, both having respected the same fundamental boundary. This reveals something profound about the nature of reality itself. Space isn't just an empty stage where events unfold. It's an active participant in the cosmic drama, capable of carrying information, of bending and flexing, of transmitting the news of distant events across vast distances. And it does all of this at precisely the cosmic speed limit, no faster and no slower. But gravity waves, these ripples in space-time itself, reveal an even more beautiful aspect of our fundamental boundary. When two black holes spiral into each other billions of light years away, when neutron stars collide in distant galaxies, when the most massive objects in the universe dance their final dance before merging, they send out waves through the very fabric of reality itself. These waves travel toward us across cosmic time, carrying the story of their creation, preserving the memory of cataclysmic events in the gentle oscillations of space-time. They move at exactly the cosmic speed limit, neither gaining nor losing energy as they cross the emptiness between galaxies. And when they finally reach us, they're still strong enough to move mirrors in our most sensitive detectors by distances smaller than a proton's width. Think about the poetry of this as you settle deeper into rest. The universe has its own way of keeping records, of preserving the memory of distant events in waves that travel faithfully across space and time. every collision, every merger, every cosmic catastrophe sends out its own unique signature, its own gravitational song, traveling at the speed limit toward any observers patient enough to listen. And we are listening. In laboratories around the world, scientists have built detectors so sensitive they can hear these cosmic whispers, these faint echoes of events that happened when the universe was young. The waves tell stories of black holes that merged before Earth was formed, of neutron stars that collided when life was just beginning to stir in ancient oceans. But here's what makes this even more remarkable. These gravitational waves, these ripples in space-time itself, don't just travel at the cosmic speed limit. They help define what that limit means. The speed of light isn't really about light at all. It's about the structure of space-time, about how information and causation propagate through the universe, about the fundamental relationship between space and time themselves. Light travels at this speed because photons have no mass, because they must ride the null geodesics of space-time, the mathematical curves that define the boundary between past and future. Gravity waves travel at this speed because they are space-time, because they are the very fabric of reality oscillating at its natural frequency. The cosmic speed limit emerges from the geometry of existence itself. This brings us to one of the most beautiful and mysterious aspects of our cosmic boundary. It's not just that nothing can go faster than this speed. It's that this speed represents something like the refresh rate of reality itself, the fundamental frequency at which the universe updates its state, computes the next moment from the current one, weaves the threads of causation into the tapestry of existence. In the quantum realm, this becomes even more apparent. The uncertainty principle, that fundamental limit on how precisely we can know certain pairs of properties, is intimately connected to the cosmic speed limit. The more precisely we try to pin down a particle's position, the more uncertain its momentum becomes, and vice versa. This isn't a limitation of our measuring instruments. It's a fundamental feature of reality that emerges from the same deep structure that gives rise to the speed limit. Even the vacuum itself, that seemingly empty space between atoms, between planets, between stars, is alive with quantum activity governed by the cosmic boundary. Virtual particles pop into existence and annihilate each other in time so brief that the cosmic speed limit prevents them from being observed directly. Yet their effects are real, measurable, fundamental to how forces operate at the smallest scales. The electromagnetic force that holds atoms together, the strong nuclear force that binds protons and neutrons in atomic nuclei, even the weak nuclear force responsible for certain types of radioactive decay, all of them operate through the exchange of virtual particles that respect the cosmic speed limit. The universe, it seems, is built from interactions that never quite violate the fundamental boundary, even at scales where that boundary might seem irrelevant. This creates a kind of cosmic democracy. Every interaction, from the smallest quantum exchange to the largest gravitational wave, plays by the same rules. The same speed limit that governs the light from distant stars also governs the forces that hold your atoms together as you lie there in the gentle darkness. But perhaps the most profound implication of the cosmic speed limit is what it tells us about the nature of time itself. We tend to think of time as flowing like a river, carrying us from past to future at a steady, universal rate. But the cosmic speed limit reveals time to be far stranger and more wonderful than this simple picture suggests. Time, it turns out, is not separate from space. It's not something that happens to the universe. It's part of the universe's fundamental structure. The cosmic speed limit is the conversion factor between space and time, the mathematical constant that determines how much distance corresponds to how much duration in the four-dimensional fabric of space-time. This means that time itself has a kind of granularity, a fundamental scale below which the very concept of duration begins to break down. At the smallest scales of space and time, distances measured in units called Planck lengths, and durations measured in Planck times, the smooth fabric of space-time begins to fluctuate and foam, revealing a quantum texture that defies our everyday understanding of continuity. The cosmic speed limit emerges from this quantum foam, from the fundamental granularity of space and time themselves. It's not imposed from outside like a cosmic traffic law. It bubbles up from the deepest level of reality, from the quantum mechanical substrate that underlies all of existence. This gives the speed limit an almost organic quality, as if it were a natural consequence of the universe's metabolism, the rate at which reality digests information and transforms it into the next moment of existence. Every photon that travels from star to eye, every gravitational wave that ripples across cosmic distances, every quantum interaction in the heart of an atom, all of them participate in this vast, interconnected process of cosmic information processing. And you, lying there in the quiet sanctuary of your bedroom, are part of this process too. Your thoughts, emerging from the complex dance of neurons and neurotransmitters, respect the same fundamental boundaries that govern the motion of galaxies. The electrical signals that carry information through your nervous system travel far slower than light, but they operate within the same framework, subject to the same ultimate constraints. Your dreams, when they come, will unfold in a realm where the ordinary rules of space and time seem suspended, where distant memories can touch present experiences, where the impossible becomes routine. Yet even in dreams, even in the strange landscape of sleep consciousness, the fundamental structures remain. The neurons that generate your dreams still fire at speeds well below the cosmic limit. The chemistry of sleep still respects the quantum mechanical rules that emerge from space-time's deepest levels. There's something almost comforting in this universality, in knowing that the same laws that govern the dance of galaxies also govern the gentle rhythm of your breathing as you drift towards sleep. The cosmic speed limit isn't a cold mathematical abstraction. It's part of the warm fabric of existence, the fundamental pulse that connects every part of reality to every other part. But our exploration has revealed something even more mysterious, lurking at the edges of our understanding. If the cosmic speed limit is truly fundamental, if it emerges from the deepest structure of space-time itself, what does this tell us about the nature of existence beyond our current theories? What happens at the very boundaries of space and time, where our familiar concepts begin to break down? These questions push us toward the frontiers of theoretical physics, toward ideas that stretch our imagination and challenge our most basic assumptions about reality. String theory suggests that the fundamental constituents of reality might be tiny, vibrating loops of energy existing in dimensions beyond the three of space and one of time that we experience directly. Loop quantum gravity proposes that space itself might be quantized, made up of discrete, indivisible units at the smallest scales. In these theories, the cosmic speed limit takes on new significance. It becomes not just a boundary for motion through space, but a fundamental feature of how information can flow between different dimensions, different scales of reality, different levels of existence. It connects the quantum foam at the smallest scales to the smooth space-time we experience in our everyday lives. Some theories even suggest that our entire universe might be a kind of hologram, with all the information that defines reality encoded on a two-dimensional surface at the cosmic boundary. In this view, the cosmic speed limit becomes the rate at which this holographic information can be processed, the fundamental bandwidth of existence itself. These ideas might sound like science fiction as you rest there in the comfortable reality of your bed, but they emerge from serious attempts to understand what happens when we push our theories to their absolute limits. They represent humanity's ongoing effort to comprehend the deepest structures of reality, to understand not just how the universe works, but why it works the way it does. And at the heart of all these investigations lies the cosmic speed limit, that fundamental constant that seems to govern not just motion and causation, but the very nature of existence itself. It's a boundary that connects the largest and smallest scales of reality, that links the quantum realm to the cosmic one, that bridges the gap between matter and information, between physics and philosophy. As we prepare to venture even deeper into these cosmic mysteries, as we ready ourselves to explore the most profound implications of the universe's fundamental speed limit, let yourself rest in the knowledge that you are part of something magnificent and strange. The same cosmic principles that govern the birth and death of stars also govern the quiet miracle of consciousness that allows you to contemplate these mysteries. The universe has spent billions of years evolving structures complex enough to understand themselves, to ask questions about their own nature, to wonder at their own existence, and you, in this quiet moment between waking and sleeping, are one of those structures. You are the universe becoming aware of itself, asking questions about its own deepest laws, marveling at its own elegant construction. The cosmic speed limit isn't just a law of physics. It's part of the foundation that makes this self-awareness possible, that allows consciousness to emerge from complexity, that enables the universe to know itself through minds like yours. In the gentle darkness of your room, surrounded by the quiet hum of a cosmos governed by elegant and mysterious laws, you embody the universe's ongoing effort to understand its own nature. But there are deeper mysteries still waiting for us, stranger implications that emerge when we truly grasp what it means for reality to have this fundamental boundary. The cosmic speed limit doesn't just govern what can happen, it governs what can be known, what can be experienced, what can be imagined. And in exploring these deepest implications, we begin to touch on questions that go to the very heart of existence itself. What happens when we push deeper into the implications of this cosmic boundary? What does it mean for consciousness itself to exist within a universe governed by such fundamental limits? As you settle deeper into the rhythm of approaching sleep, let's explore how the cosmic speed limit shapes not just the motion of particles and planets, but the very nature of awareness, of knowledge, of what it means to exist as a thinking being in a universe with rules. Consider the thoughts flowing through your mind right now, the gentle stream of consciousness that accompanies you towards sleep. Each thought emerges from patterns of electrical activity in your brain, signals racing along neural pathways at speeds that seem lightning fast from a biological perspective but are glacially slow compared to our cosmic speed limit. A nerve impulse travels at perhaps 120 meters per second, roughly 1/1,000,000th the speed of light. Yet this seemingly sluggish pace is exactly what allows the complex, layered processing that gives rise to consciousness. This creates a fascinating paradox. Your thoughts, your awareness, your very sense of self emerges from processes that operate far below the cosmic speed limit. In the time it takes a single thought to form in your mind, light could travel to the moon and back several times over. Yet consciousness, this seemingly magical emergence of inner experience from neural activity, requires precisely this slower tempo, this more measured pace of information processing. Why should this be so? The answer lies in the nature of complexity itself. Consciousness doesn't emerge from simple, high-speed processes, but from intricate networks of slower interactions, from the patient accumulation of small influences, from the gradual building of patterns that span multiple scales of space and time. Your brain is not a computer trying to operate as close to the cosmic speed limit as possible. It's an ecosystem of information processing that has evolved to operate at exactly the speeds that allow awareness to emerge. This reveals something profound about the relationship between intelligence and the cosmic speed limit. The universe's fundamental boundary doesn't constrain consciousness, it enables it. By preventing information from traveling too quickly, by enforcing a maximum rate of causation. The cosmic speed limit creates the stable, predictable environment in which complex systems like brains can evolve and operate. Imagine a universe without this speed limit, where influences could propagate instantaneously across any distance. In such a universe, every part would be immediately affected by changes in every other part. There would be no local stability, no persistent patterns, no opportunity for the kind of gradual, hierarchical organization that consciousness requires. The cosmic speed limit doesn't limit the universe's potential for complexity. It makes that complexity possible. But the relationship between consciousness and the cosmic boundary goes even deeper. Your ability to know anything about the universe, to gather information about distant stars or ancient events, depends entirely on the patient journey of light and other signals across cosmic distances. Every piece of knowledge you possess about the world beyond your immediate vicinity has traveled to you at exactly the cosmic speed limit, carrying information from its source to your senses. This creates what we might call the light cone of consciousness. Everything you can possibly know about the universe at any given moment lies within a cone-shaped region of space-time, bounded by signals that have had time to reach you while traveling at the cosmic speed limit. This cone expands constantly as new information arrives, but its boundaries are absolute. There are regions of space and time that are simply unknowable to you right now, not because they don't exist, but because information from them hasn't had time to reach you yet. This might seem like a limitation, but it's actually what makes knowledge meaningful. In a universe without the cosmic speed limit, where information could travel instantaneously, you would theoretically have access to all information everywhere all at once. But this wouldn't be enlightenment. It would be chaos. The human mind, any mind, requires information to arrive in manageable doses, in sequences that allow for processing, comparison, and understanding. The cosmic speed limit ensures that information reaches you at exactly the pace that allows consciousness to function. It creates a natural filtering system, a cosmic bandwidth limitation that prevents sensory overload while ensuring that the information you do receive is causally coherent, arriving in the proper sequence to maintain the logical structure of cause and effect. Think about this as your breathing slows and your thoughts begin to drift. The starlight touching your skin right now left its source years, decades, or centuries ago. Each photon has traveled faithfully at the cosmic speed limit to reach you at this precise moment. The information encoded in that light about the temperature, composition, and motion of distant stars has been preserved perfectly during its journey, protected by the fundamental laws that govern the propagation of information through space-time. This creates a kind of cosmic memory system. The universe preserves information about its past states in the light and other signals that continuously propagate outward from every event. Your eyes, right now, are receiving messages from the cosmic past, photons that carry the preserved memory of stellar surfaces, of planetary atmospheres, of the cosmic microwave background that still echoes from the universe's earliest moments. In a very real sense, looking outward into space is looking backward in time. The further you can see, the deeper into the cosmic past you peer. This isn't metaphorical, it's a direct consequence of the cosmic speed limit. Information about distant events takes time to reach you, so you always see things as they were, not as they are. The most distant galaxies visible to our telescopes appear as they existed when the universe was young, their light having traveled for billions of years to reach us. This temporal structure of information creates something like a cosmic archaeology. Each layer of distance corresponds to a different epoch in cosmic history. By looking at objects at different distances, astronomers can reconstruct the story of how the universe has evolved, how galaxies formed, how stars were born and died, how the cosmos itself has changed over time. But this cosmic archaeology is only possible because of the speed limit. If information could travel instantaneously, we would see everything in the universe as it exists right now, and we would lose access to this vast library of cosmic history. The cosmic speed limit doesn't just govern motion, it governs memory, preserving the universe's past states in the form of traveling information that takes time to propagate. This preservation of information has profound implications for the nature of existence itself. In some theories of physics, information is considered to be the most fundamental constituent of reality, more basic than matter or energy. The cosmic speed limit, in this view, becomes the fundamental rate at which the universe can process information, the maximum bandwidth of reality itself. Every interaction between particles, every measurement, every quantum collapse, every thought in your mind represents a kind of information processing. The cosmic speed limit ensures that all of this processing happens at a rate that preserves causality, that maintains the logical structure of cause and effect, that allows the universe to remain comprehensible to conscious observers like yourself. But consciousness introduces another layer of mystery into this cosmic information system. You are not just a passive receiver of information traveling at the speed limit. You are an active processor, a local concentration of information transformation that can take raw sensory data and transform it into understanding, meaning, subjective experience. This transformation happens entirely within your light cone, within the region of spacetime that can causally influence you. Yet somehow, from this limited perspective, from this narrow slice of cosmic information, you are able to construct models of the entire universe, to understand laws that operate far beyond your direct experience, to imagine scenarios that extend far beyond your local light cone. This suggests something remarkable about the nature of consciousness and its relationship to the cosmic speed limit. While you are constrained by the fundamental boundary in terms of what information can reach you and when, your ability to process and understand that information allows you to transcend those constraints in a different way. Through reasoning, imagination, and mathematical modeling, you can understand aspects of reality that lie far beyond your direct observational reach. The cosmic speed limit shapes what you can know directly, but it doesn't limit what you can understand. Through the patient accumulation of information arriving at the fundamental velocity, through the careful analysis of patterns and relationships, through the construction of theories that extend beyond immediate observation, consciousness finds ways to explore the universe that go far beyond the simple reception of traveling signals. This creates a beautiful complementarity between the cosmic speed limit and consciousness. The limit provides the stable, causal structure that allows complex information processing to evolve and operate. Consciousness, in turn, finds ways to explore and understand the universe that go beyond the immediate constraints imposed by the finite speed of information propagation. As you drift towards sleep, as your conscious processing slows and changes into the different patterns of dream consciousness, you remain part of this vast cosmic information system. Your brain continues to process signals that have traveled to you at the cosmic speed limit. Your neurons continue to fire in patterns that respect the fundamental boundaries of space-time. Yet in dreams, these constraints seem to dissolve, allowing for experiences that transcend the normal limitations of space and time. Dreams represent a fascinating case study in how consciousness relates to the cosmic speed limit. In the dream state, your brain can simulate experiences that seem to violate the fundamental laws of physics. You can appear to travel faster than light, to communicate instantaneously across vast distances, to experience events that seem to unfold outside the normal causal structure of space-time. Yet these dream experiences, however vivid and seemingly impossible, still emerge from neural processes that operate well within the cosmic boundaries. The electrical and chemical signals that generate dreams still respect the speed limit. The information processing that creates dream narratives still unfolds at biological speeds far below the fundamental velocity. This suggests that consciousness has evolved a remarkable ability to simulate realities that extend beyond the constraints that govern its physical substrate. While your brain operates within the cosmic speed limit, your mind can imagine scenarios that transcend those limits. This capacity for transcendent imagination might be one of consciousness's most remarkable features, allowing it to explore possibilities that go far beyond immediate physical constraints. But even this transcendent capacity operates within a framework shaped by the cosmic speed limit. The very concepts you use to imagine faster-than-light travel, instantaneous communication, or non-causal sequences depend on your understanding of the normal, speed-limited universe. You can only imagine transcending the cosmic boundary because you first understand what that boundary means, how it shapes normal experience, why it matters for the structure of reality. This creates a kind of dialectical relationship between consciousness and the cosmic speed limit. The limit shapes the evolution and operation of consciousness by providing a stable, causal framework. Consciousness, in turn, develops the capacity to understand and even imaginatively transcend that framework. Yet this transcendence is itself enabled by the stable foundation that the speed limit provides. The cosmic speed limit also shapes the social and cultural dimensions of consciousness. Every human interaction, every exchange of information between minds, is mediated by signals that travel at or below the fundamental velocity. Language, whether spoken, written, or transmitted electronically, propagates through space at speeds that respect the cosmic boundary. This creates natural delays, gaps, and limitations that shape how we communicate, how we share knowledge, how we build collective understanding. These limitations aren't obstacles to overcome, but features that enable meaningful communication. The fact that information takes time to travel from one mind to another creates space for reflection, for processing, for the kind of careful consideration that allows knowledge to be truly shared rather than simply transmitted. Instant, unlimited communication might seem desirable, but it would likely overwhelm the capacity of individual minds to process and integrate information meaningfully. The cosmic speed limit creates a natural rhythm for the exchange of information between conscious beings. It ensures that communication happens at a pace that allows for understanding, that preserves the possibility of dialogue, rather than simply creating an overwhelming flood of data. In this way, the fundamental boundary that governs the universe also governs the evolution of culture, knowledge, and collective consciousness. But perhaps the most profound way that the cosmic speed limit shapes consciousness is through its role in creating the arrow of time, the directional flow from past to future that gives structure to all conscious experience. Without this fundamental boundary, without the constraint that information cannot travel faster than light, the universe would be a place where effects could precede causes, where the sequence of events could become scrambled and meaningless. The cosmic speed limit preserves the causal order that makes narrative possible, that allows consciousness to construct coherent stories about experience, that enables memory to accumulate and learning to occur. Your ability to remember the past and anticipate the future depends on the reliable directional flow of causation that the speed limit maintains. This directional flow creates the temporal structure within which all conscious experience unfolds. Your thoughts follow each other in sequence. Your memories are organized chronologically. Your plans and expectations are oriented toward a future that emerges predictably from the present. All of this depends on the cosmic speed limit's protection of causal order. As you settle into the approaching realm of sleep, as your consciousness prepares to transform into the different patterns of dream awareness, you remain embedded in this cosmic framework of causation and information flow. The thoughts that fade as you drift towards sleep do so in an orderly sequence, following patterns that respect the fundamental boundaries of space-time. The dreams that will come will emerge from neural processes that operate within the cosmic speed limit, even as they simulate experiences that seem to transcend all physical constraints. In the deepest sense, consciousness and the cosmic speed limit are partners in the universe's ongoing project of creating meaning, structure, and understanding. The speed limit provides the stable framework within which consciousness can evolve and operate. Consciousness, in turn, represents the universe's most remarkable achievement within that framework. The emergence of awareness, understanding, and the capacity for wonder that allows the cosmos to know itself. But our exploration of how the cosmic speed limit shapes consciousness has revealed something even more mysterious. If consciousness emerges from processes that operate within this fundamental boundary, and if consciousness can understand and even imaginatively transcend that boundary, what does this tell us about the relationship between mind and reality? Are there aspects of consciousness that somehow exist beyond the normal constraints of space-time? And what might this mean for our understanding of the deepest nature of existence itself? These questions push us toward the very frontiers of what we can know or even meaningfully ask about the universe. They touch on mysteries that may ultimately be unsolvable, not because we lack the right tools or theories, but because they probe the very foundations of knowledge and existence themselves. Yet in asking these questions, in pushing against the boundaries of understanding, consciousness demonstrates its most remarkable feature: the capacity to reach beyond its own limitations, to explore possibilities that extend far beyond the immediate constraints of physical existence. The cosmic speed limit doesn't just govern motion through space and time. It governs the very possibility of knowledge, of communication, of consciousness itself. And consciousness, emerging within these constraints, somehow finds ways to transcend them, at least in imagination and understanding. This dance between limitation and transcendence, between constraint and creativity, between the bounded and the boundless, may be the most beautiful consequence of the universe's fundamental speed limit. In the gentle darkness of your room, as sleep approaches and consciousness prepares to transform itself once again, you embody this cosmic dance. You are matter organized in such a way that it can understand itself, energy configured to contemplate its own existence, information processing that has become aware of its own processing. The cosmic speed limit made your existence possible, and your existence gives meaning to the cosmic speed limit. But there's one final layer of mystery waiting for us, one last implication of the cosmic boundary that touches on the deepest questions about the nature of reality itself. If the universe has this fundamental speed limit, if information and causation cannot propagate faster than light, what does this tell us about the ultimate structure of existence? Are we living in something like a cosmic simulation, with the speed limit representing a fundamental processing constraint? Or does the boundary point toward even stranger possibilities about the nature of space, time, and consciousness itself? As we drift deeper into these cosmic mysteries, as your consciousness prepares to slip into the different realm of sleep, let's explore one of the most profound implications of our universal speed limit. You see, this boundary doesn't just govern how fast things can move or how quickly information can travel. It may actually tell us something fundamental about the very nature of reality itself, something that challenges our most basic assumptions about what it means for the universe to exist. Consider this gentle thought as you settle into your pillow. Every computation your brain performs right now, every electrical signal racing through your neural networks, every quantum interaction in the molecular machinery of your cells, all of it happens at finite speeds. All of it respects certain processing limits. Your consciousness emerges from billions of tiny calculations happening simultaneously, each one constrained by the fundamental laws of physics, each one operating within the cosmic speed limit's ultimate framework. This raises a fascinating question that physicists and philosophers have begun to whisper about in recent years. What if the universe itself is something like a vast computation? Not a computer in the sense of circuits and silicon, but a deeper kind of information processing system where the laws of physics are the algorithms, where particles and forces are the data, and where the cosmic speed limit represents the maximum processing speed of reality itself. In this view, every interaction between particles becomes a kind of calculation. Every quantum measurement becomes a moment where the universe computes the next state from the current one. Every propagation of a wave, every gravitational influence, every electromagnetic pulse becomes part of a vast, ongoing computation that we call physical reality. The cosmic speed limit, in this perspective, isn't just a constraint on motion, it's the fundamental clock speed of the universe's processor, the maximum rate at which reality can update itself, the ultimate bandwidth of existence. Just as your computer has limits on how quickly it can perform calculations, the universe may have its own computational constraints, its own processing bottlenecks that manifest as the speed of light. This computational view helps explain some of the strangest features of our cosmic boundary. Why should there be a maximum speed at all? In a computational universe, processing speed limits emerge naturally from the underlying architecture. Why should massive objects become infinitely heavy as they approach this speed? Perhaps because accelerating them requires exponentially more computational resources, more processing power than the universe's finite capacity can provide. But don't let this computational metaphor make the universe seem cold or mechanical as you lie there in the warm comfort of your bed. If reality is indeed a kind of computation, it's a computation of unimaginable beauty and complexity, one that has somehow computed its way to consciousness, to love, to wonder, to the quiet moment you're experiencing right now. The patterns that emerge from this cosmic computation aren't just mathematical abstractions. They're galaxies and stars, planets and oceans, life and thought and dream. The universe's processing power, constrained though it may be by the cosmic speed limit, has proven sufficient to compute the intricate dance of chemistry that becomes biology, the complex networks of neural activity that become consciousness, the delicate balance of forces that allows stable structures to persist across cosmic time. And here's something that might surprise you. If the universe is indeed computational, then you are not just a product of that computation. You are part of the computation itself. Every thought you think, every decision you make, every moment of awareness contributes to the ongoing calculation that we call reality. You're not just observing the universe, you're helping to compute it. This creates a kind of recursive loop that philosophers and scientists find endlessly fascinating. The universe computes consciousness, and consciousness computes understanding of the universe, which affects how consciousness behaves, which changes the universe's computation, which changes consciousness, and so on in an endless dance of mutual influence and co-creation. The cosmic speed limit governs this entire process, ensuring that the feedback loops remain stable, that the computation doesn't spiral into chaos, that the universe's self-awareness through consciousness unfolds in an orderly, causal fashion. It's as if the cosmos has evolved its own built-in debugging system, a set of constraints that prevent the calculation from crashing or producing meaningless results. But this computational perspective raises even deeper questions about the nature of existence. If reality is a kind of computation, what is it being computed on? What is the substrate, the underlying hardware that runs the software we call physical law? Some theories suggest that this substrate might be pure information, that the universe is made not of matter and energy, but of bits and algorithms, of data and processing rules. In this view, what we call particles and forces are really patterns in the information flow, stable configurations in the data stream that persist long enough to seem like solid objects. Your body, your bed, the air you breathe, All of it would be information organized in particular ways, maintained by the ongoing computation that we experience as physical reality. The cosmic speed limit becomes the maximum rate at which this information can be processed, the fundamental bandwidth of the information flow that constitutes existence. It's not that photons are special particles that happen to travel at this speed. It's that the cosmic speed limit represents the maximum rate at which any information can propagate through the computational substrate of reality. This might sound strange as you drift towards sleep, but it actually explains many of the mysterious features of quantum mechanics that have puzzled physicists for decades. The uncertainty principle, which says you can't know both the position and momentum of a particle with perfect precision, might reflect fundamental limits on how much information the universe can store and process about any given system. Quantum entanglement, the spooky action at a distance that Einstein found so troubling, might be better understood as shared information processing, where entangled particles are really different aspects of the same computational process, different variables in the same cosmic calculation. Even the measurement problem in quantum mechanics, the puzzle of how quantum possibilities collapse into definite outcomes, might be understood as the universe making computational choices, selecting specific values from ranges of possibilities based on the complex algorithms we call physical laws. The cosmic speed limit ensures that all of these quantum computations happen in a coordinated way, that the universe's calculation remains coherent across space and time, that the information processing that constitutes reality unfolds in an orderly fashion that preserves causality and meaning. But perhaps the most remarkable implication of this computational view is what it suggests about consciousness itself. If the universe is a vast information processing system, then consciousness might be understood as a special kind of subroutine, a particular pattern of computation that has evolved the capacity for self-awareness, for recursive self-reference, for the strange loop of being able to think about thinking. Your dreams, when they come tonight, might be understood as a different mode of information processing, a way your brain reorganizes and processes the day's accumulated data. The strange logic of dreams, where impossible things seem perfectly natural, might reflect the brain's computational constraints being relaxed, allowing for more creative, less causally constrained information processing. The cosmic speed limit still governs even your dreaming brain, still constrains the electrical and chemical processes that generate dream consciousness. But within those constraints, your mind finds ways to explore possibilities that seem to transcend normal physical limitations, to experience realities that stretch and bend the usual rules of space and time. This computational perspective also suggests intriguing possibilities about the future evolution of consciousness and its relationship to the cosmic speed limit. As we develop better understanding of information processing, as we create artificial intelligences and quantum computers, we might discover new ways to explore the boundaries of the cosmic computation. Perhaps we'll find ways to optimize our own information processing, to work more efficiently within the constraints imposed by the speed limit. Perhaps we'll discover that consciousness itself can be understood as a kind of quantum computation, one that takes advantage of the strange properties of quantum mechanics to process information in ways that classical systems cannot. Or perhaps we'll discover that the cosmic speed limit isn't as absolute as it seems, that there are loopholes in the universe's computational architecture, ways to process information that circumvent the usual constraints. Quantum entanglement already suggests that some kinds of information sharing might happen instantaneously, even across vast distances, without violating the speed limit in any obvious way. These possibilities remain speculative, of course, hovering at the edge of our current understanding like dreams at the edge of sleep. But they remind us that the cosmic speed limit, fundamental though it may be, is part of a reality that continues to surprise us, to reveal new layers of complexity and beauty, to offer new mysteries for consciousness to explore. As you settle deeper into the approaching realm of sleep, as your brain's information processing shifts into the different patterns of dream consciousness, you remain part of this cosmic computation. Your thoughts, your memories, your dreams all emerge from processes that respect the fundamental speed limit, yet somehow transcend it through the miracle of awareness, understanding, and imagination. The universe may be computational, but it's a computation that has computed its way to wonder, to beauty, to the capacity for a pattern of information to recognize itself, to ask questions about its own existence, to marvel at the elegant constraints that make its consciousness possible. In the gentle darkness of your room, surrounded by the quiet hum of a cosmos that might be thinking itself into existence moment by moment, you embody the universe's most remarkable achievement, the emergence of self-aware information processing from the patient, law-governed computation of reality itself. But even this computational perspective, beautiful and explanatory though it may be, pushes us toward an even deeper mystery. If the universe is indeed a vast computation, if consciousness is a pattern in that computation, if the cosmic speed limit represents the processing constraints of reality itself, then what lies beyond these constraints? Are there aspects of existence that operate outside the universal computation? Are there realms of reality that transcend even the cosmic speed limit? These questions take us to the very edge of what physics and philosophy can meaningfully address. They probe the boundaries not just of our knowledge, but of knowledge itself. Yet in asking them, in pushing against the limits of understanding, we demonstrate something profound about the nature of consciousness and its relationship to the cosmic order. Perhaps the most beautiful aspect of the cosmic speed limit is how it enables this very questioning. By providing a stable, causal framework within which consciousness can evolve and operate, the speed limit makes possible the emergence of minds capable of wondering about their own existence, of asking questions that reach beyond immediate experience, of imagining possibilities that transcend current understanding. The cosmic speed limit doesn't constrain wonder, it enables it. It doesn't limit imagination. It provides the foundation upon which imagination can build. It doesn't prevent transcendence. It creates the stable platform from which consciousness can reach toward the transcendent. And so, as sleep approaches, as your conscious mind prepares to dissolve into the different patterns of dream awareness, you can rest in the knowledge that you are part of something magnificent and mysterious. The same cosmic principles that govern the dance of galaxies also govern the gentle rhythm of your breathing, the quiet pulse of your heart, the subtle electrical activity of your dreaming brain. The universe has spent billions of years computing its way to this moment, to this quiet sanctuary where consciousness can contemplate its own cosmic context, where a pattern of organized matter and energy can ask questions about the nature of existence itself. You are not separate from the cosmic computation. You are one of its most beautiful and complex expressions. The cosmic speed limit made your existence possible, shaped the evolutionary processes that led to consciousness, governed the information flows that allow knowledge and understanding to accumulate across generations. And consciousness, emerging within these constraints, has found ways to explore realities that seem to transcend all physical limitations, to imagine possibilities that stretch far beyond the boundaries of immediate experience. This dance between limitation and transcendence, between constraint and creativity, between the bounded and the boundless, may be the universe's greatest achievement. In you, in this quiet moment of reflection and wonder, the cosmos has created something capable of understanding itself, of appreciating its own beauty, of marveling at its own elegant construction. The cosmic speed limit isn't just a law of physics. It's part of the deep structure that makes meaning possible, that allows complexity to emerge from simplicity, that enables the universe to know itself through minds like yours. In the gentle darkness, surrounded by the patient computation of reality itself, You embody the universe's capacity for self-awareness, for wonder, for the kind of understanding that transcends even the fundamental boundaries that make it possible. But our journey through these cosmic mysteries isn't quite complete. There's one final implication of the universal speed limit that we haven't fully explored. One last way that this fundamental boundary shapes not just the universe we observe, but the very nature of observation itself. As consciousness prepares to transform into the strange realm of dreams, let's consider how the cosmic speed limit affects not just what can happen in the universe, but what can be known about what happens, what can be measured, what can be experienced by conscious observers like yourself. The cosmic speed limit doesn't just govern what happens in the universe, it governs what can be witnessed, what can be measured, what can be known by any conscious observer. As you lie there in the gentle transition between waking and dreaming, consider this profound truth. Every piece of information you've ever received about the world, beyond your immediate touch, has traveled to you at exactly this fundamental velocity. Not faster, not slower, but at precisely the cosmic speed limit. This creates something physicists call the observable universe, a sphere of knowability that surrounds you at every moment. It's not that the universe ends at this boundary, it's that beyond this sphere lies information that simply hasn't had time to reach you yet, signals still making their patient journey across cosmic distances, stories still unfolding in the darkness beyond your capacity to witness them. Right now, as your breathing deepens and your thoughts begin to drift, this sphere of observation is expanding around you at exactly the speed of light. New information is arriving constantly, photons from distant stars completing journeys that began before your grandparents were born, carrying tales of stellar surfaces and planetary atmospheres across the emptiness of space to touch your skin with their ancient warmth. But here's where the mystery deepens, where the cosmic speed limit reveals its most profound influence on the nature of knowledge itself. Because this boundary exists, because information cannot travel instantaneously, the act of observation becomes fundamentally different from what our intuition might suggest. When you observe something, you're not seeing it as it is right now. You're seeing it as it was when the light left it, when the information began its journey toward your eyes. This temporal displacement becomes more dramatic the farther you look. The sun you see is 8 minutes in the past. The nearest star beyond our solar system appears as it was over 4 years ago. The most distant galaxies visible to our telescopes appear as they existed when the universe was young, their light carrying messages from cosmic childhood across billions of years to reach your present moment. This means that observation itself is a form of time travel, a way of reaching into the cosmic past through the patient journey of light. But it's not the kind of time travel that science fiction imagines, where you might change the past or create paradoxes. It's a gentler, more beautiful form of temporal connection, where the past reaches forward to touch the present through the faithful propagation of information at the cosmic speed limit. Every glance upward at the night sky becomes an act of cosmic archaeology. You're not just seeing distant objects, you're excavating layers of cosmic history, peeling back the years and centuries and millennia to witness events that happened when the universe was different, younger, stranger than it is today. The cosmic speed limit preserves these moments in traveling light, creating a vast library of cosmic memory that unfolds around you in all directions. But this temporal structure of observation has even stranger implications when we consider it carefully. Because the cosmic speed limit is absolute, because it applies to all information equally. Different observers moving at different velocities will disagree about the timing of distant events. What seems simultaneous to you might appear sequential to someone moving rapidly relative to you. The cosmic speed limit doesn't just preserve causality, it makes simultaneity itself a relative observer-dependent phenomenon. This relativity of simultaneity touches something deep about the nature of existence itself. There is no universal now that applies everywhere in the cosmos. The present moment, that intimate experience you're having right now, as these words flow through your consciousness, is actually a local phenomenon, bounded by the sphere of space from which information has had time to reach you. Think about this as your thoughts begin to slow and soften. The now you're experiencing includes everything within your light cone, everything that can causally influence this moment. But beyond that boundary lies a vast realm of events that are happening now, in some sense, but which exist outside your current present moment because information about them hasn't had time to reach you. This creates a kind of cosmic loneliness, but also a cosmic intimacy. You are forever isolated from the absolute present moments of distant observers, unable to share a truly simultaneous now with anyone beyond your immediate vicinity. Yet this isolation is also what makes local experience possible, what allows consciousness to emerge and operate within a stable causal framework. The cosmic speed limit ensures that your experience of the present moment isn't overwhelmed by simultaneous information from everywhere in the universe. Instead, it creates a natural filtering system, a cosmic bandwidth limitation that allows consciousness to process information in manageable doses, in sequences that preserve meaning and causality. But observation has quantum mechanical aspects that make the cosmic speed limit even more mysterious and beautiful. At the smallest scales, the act of measurement becomes a creative process, where the observer doesn't just discover pre-existing properties, but actually participates in determining the outcome of quantum events. The cosmic speed limit governs these quantum interactions just as it governs classical motion, ensuring that quantum information cannot propagate faster than light, that quantum measurements unfold in ways that preserve causal order. This quantum dimension of observation suggests that consciousness isn't just a passive receiver of information traveling at the cosmic speed limit. It's an active participant in the universe's ongoing computation, a local concentration of information processing that can influence the very events it observes. The boundary between observer and observed becomes blurred at the quantum level, revealing a universe where consciousness and physical reality are more intimately connected than classical physics ever imagined. Yet even these quantum effects respect the cosmic speed limit. Quantum entanglement, that strange phenomenon where particles seem to influence each other instantaneously across vast distances, doesn't actually allow faster-than-light communication. The correlations between entangled particles can appear instantly, but no information can be transmitted through these correlations without additional classical communication that respects the speed limit. This preservation of the cosmic boundary, even in the quantum realm, suggests something profound about the nature of reality itself. The universe seems to be constructed in such a way that its fundamental processing speed cannot be exceeded, that information cannot be transmitted faster than the cosmic limit, even through the strangest and most counterintuitive quantum phenomena. As your consciousness prepares to slip into the different realm of sleep, as your brain's information processing shifts into the patterns of dream awareness, these quantum effects continue to operate in the molecular machinery of your neurons. The electrical signals that will generate your dreams still respect the cosmic speed limit. The chemical communications between brain cells still unfold at speeds far below the fundamental boundary. Yet dreams seem to transcend these limitations, allowing consciousness to experience impossible journeys, instantaneous transportation, communication across vast distances without delay. This apparent transcendence happens not because dreams violate the cosmic speed limit, but because consciousness has evolved the remarkable capacity to simulate realities that seem to extend beyond physical constraints. In dreams, your brain can model scenarios where the cosmic speed limit doesn't apply. where information travels instantly, where cause and effect become scrambled in impossible ways. These simulations emerge from neural processes that strictly respect the fundamental boundary, yet they allow consciousness to explore possibilities that stretch far beyond immediate physical limitations. This capacity for transcendent simulation might be one of consciousness's most remarkable features, one that distinguishes aware information processing from simple computation. While your brain operates within the cosmic speed limit, your mind can imagine scenarios that transcend it, can explore realities where different rules apply, can contemplate possibilities that extend far beyond current physical understanding. The cosmic speed limit doesn't constrain imagination. It enables it by providing a stable foundation from which consciousness can reach toward the transcendent. Without this fundamental boundary, without the causal order it preserves, consciousness might never evolve the capacity for coherent thought, let alone transcendent imagination. But observation has social and cultural dimensions that the cosmic speed limit shapes in profound ways. Every human conversation, every exchange of ideas, every transmission of knowledge between minds is mediated by signals that respect the fundamental boundary. Language propagates through space at speeds well below the cosmic limit, creating natural delays and gaps that shape how we communicate, how we share understanding, how we build collective knowledge. These delays aren't obstacles to meaningful communication. They're features that enable it. The fact that information takes time to travel from one mind to another creates space for reflection, for processing, for the kind of careful consideration that allows knowledge to be truly shared rather than simply transmitted. The cosmic speed limit creates a natural rhythm for human interaction, ensuring that communication happens at a pace that allows for understanding and meaningful exchange. This rhythmic constraint shapes the evolution of culture, knowledge, and collective consciousness. Scientific understanding accumulates gradually, with each generation building on the discoveries of previous ones, information flowing at biological and technological speeds that respect the cosmic boundary. The cosmic speed limit ensures that knowledge develops in a measured way that allows for verification, for peer review, for the careful construction of reliable understanding. Even our modern telecommunications, seemingly instantaneous from a human perspective, actually respect the cosmic speed limit. Radio waves, internet signals, satellite communications all propagate at or below the speed of light, creating tiny delays that shape the rhythm of global communication. These delays are usually imperceptible in daily life, but they become noticeable across astronomical distances, reminding us that even our most advanced technologies operate within the cosmic framework. The cosmic speed limit also shapes our relationship with the universe's deep time, with the vast scales of cosmic evolution that dwarf human experience. Because information takes time to travel across cosmic distances, we observe the universe not as it is, but as it was across a range of different epochs. This temporal layering of observation allows us to witness cosmic evolution directly, to see galaxies at different stages of development, to observe the universe's history unfolding in the light that reaches us from different distances. This observational time travel isn't just scientifically valuable, it's spiritually profound. It connects us directly to the cosmic past, makes us witnesses to events that happened long before Earth existed, allows us to participate in the universe's memory of itself. The cosmic speed limit doesn't isolate us from cosmic history. It makes us part of it, allows us to receive and preserve information about the universe's deep past. As sleep approaches, as your personal observation of the world begins to shift into the different patterns of dream consciousness, you remain embedded in this cosmic observational framework. Your eyes, even closed, continue to receive photons that have traveled faithfully at the cosmic speed limit to reach you. your brain continues to process information that has propagated through space and time according to the fundamental laws that govern all observation. The dreams that will come represent a different kind of observation, an internal exploration of possibilities that seems to transcend normal physical constraints. Yet even dream consciousness emerges from processes that respect the cosmic speed limit, from neural networks operating within the fundamental boundaries that govern all information processing in the universe. In dreams, observation becomes creation, where consciousness doesn't just receive information, but actively generates experiences that seem to extend beyond the normal limitations of space and time. The cosmic speed limit provides the stable foundation that makes this creative transcendence possible, ensuring that even the strangest dream experiences emerge from processes that respect the deep order of reality. The boundary between observation and creation, between discovery and invention, becomes blurred in the realm of consciousness. As an observer, you don't just passively receive information traveling at the cosmic speed limit. You actively process, interpret, and transform that information into understanding, meaning, subjective experience. You participate in the universe's ongoing observation of itself, contributing your unique perspective to the cosmic conversation between matter and mind. This participatory aspect of observation suggests that consciousness isn't separate from the physical processes it observes. You're not an external witness to the cosmic computation. You're part of it, a local concentration of information processing that can observe and influence the very reality from which it emerges. The cosmic speed limit governs this entire process, ensuring that the feedback between consciousness and reality unfolds in an orderly, causal fashion. But perhaps the most beautiful aspect of how the cosmic speed limit shapes observation is how it connects every conscious observer to the vast web of cosmic causation. Every piece of information you've ever received, every photon that has ever reached your eyes, every signal that has ever touched your consciousness has traveled faithfully at the fundamental velocity, carrying messages from across space and time to contribute to your understanding of the universe. You are not isolated from the cosmos. You're intimately connected to it through the patient journey of information at the cosmic speed limit. Every moment of awareness represents a convergence of signals that have traveled from across the universe to meet in the focal point of your consciousness, creating the rich, complex experience of being an aware observer in a causally connected cosmos. The cosmic speed limit doesn't limit observation. It enables it by creating the stable, predictable framework within which consciousness can evolve, operate, and explore the depths of reality. Without this fundamental boundary, observation itself might be impossible, overwhelmed by chaotic information flows that destroyed the very possibility of coherent experience. Instead, we live in a universe where observation is both constrained and enabled by the cosmic speed limit, where consciousness can emerge and flourish within the gentle boundaries that preserve causality, meaning, and the possibility of understanding. As you drift towards sleep, as your observation of the external world fades into the internal landscapes of dream, you remain part of this cosmic observational network, connected through the fundamental laws of information propagation to every other conscious observer in the universe. The cosmic speed limit ensures that this network remains stable, that observation remains meaningful, that consciousness can continue its ancient project of helping the universe know itself through the miracle of aware, participatory observation. In the gentle darkness of approaching sleep, surrounded by the quiet flow of information at the cosmic speed limit, you embody the universe's capacity for self-observation, for the kind of aware witnessing that transforms mere computation into conscious experience. But there's one final mystery waiting for us in the gentle space between waking and sleeping. One last implication of the cosmic speed limit that touches on the deepest questions about the nature of existence itself. As consciousness prepares to transform into the strange realm of dreams, let's explore how this fundamental boundary shapes not just what can be observed, but what it means to exist as an observer in a universe governed by such elegant and mysterious laws. And now, as we reach the gentle conclusion of our cosmic journey together, as your breathing has found its deepest rhythm and your thoughts have begun to dissolve into the soft embrace of approaching sleep, let us rest in this final understanding. The cosmic speed limit isn't just a number, isn't just a law written in the cold language of physics. It's the heartbeat of existence itself, the gentle pulse that allows the universe to unfold in all its magnificent complexity. You've travelled with me tonight through realms of thought that stretch from the quantum foam at reality's smallest scales to the vast cosmic horizon at its largest. We've explored how this fundamental boundary shapes motion and causation, time and space, consciousness and observation. But perhaps most beautifully, we've discovered that this limit doesn't constrain the universe's potential. It enables it. Without this cosmic speed limit, there would be no stable atoms, no persistent stars, no patient evolution of complexity from simplicity. There would be no reliable sequence of cause and effect, no arrow of time pointing consistently forward, no framework within which consciousness could emerge and flourish. The universe would be a chaos of instantaneous influences, where every part affected every other part simultaneously, where meaning itself would dissolve in the overwhelming flood of unfiltered information. Instead, we live in a cosmos where information flows at exactly the right speed to allow beauty to emerge, where light travels faithfully across billions of years to bring us messages from the cosmic past, where consciousness can evolve within stable, causal frameworks that preserve the possibility of understanding, where minds like yours can contemplate the very laws that make their existence possible. The cosmic speed limit creates a universe of stories where events unfold in meaningful sequences, where the past influences the present and the present shapes the future. It's the foundation upon which all narrative rests, the deep structure that allows the cosmos to tell coherent tales of stellar birth and galactic dance, of chemical evolution and biological complexity, of consciousness awakening to its own cosmic context. As sleep takes you now, as your awareness dissolves into the different realm of dreams, you carry with you this knowledge. You are not separate from the cosmic story. You are one of its most beautiful chapters, a pattern of organized matter and energy that has learned to contemplate its own existence, to ask questions about the nature of reality, to marvel at the elegant laws that govern the dance of galaxies and the flutter of thoughts. The same cosmic speed limit that governs the motion of distant quasars also governs the gentle electrical activity in your dreaming brain. The same fundamental boundary that shapes the propagation of gravitational waves across the universe also shapes the flow of information through your neural networks. You are part of the cosmic computation, a local expression of the universe's ongoing project of creating complexity, consciousness, and understanding. In your dreams tonight, you may experience impossible journeys, instantaneous travels across vast distances, communications that seem to transcend all physical limitations. These dream experiences don't violate the cosmic speed limit. They transcend it through the miracle of imagination, through consciousness's remarkable capacity to simulate realities that stretch beyond immediate constraints. But even as your dreams seem to break every rule of physics, they emerge from processes that respect the deepest laws of reality. Your sleeping brain operates within the cosmic framework, its neurons firing in patterns governed by the same fundamental principles that shape the birth of stars and the collision of galaxies. The cosmic speed limit made your dreams possible by creating the stable universe within which consciousness could evolve. And consciousness, emerging within these constraints, has found ways to explore possibilities that seem to transcend all boundaries. This dance between limitation and transcendence, between constraint and creativity, may be the universe's greatest achievement. So rest now in the knowledge that you are held by laws both gentle and absolute, surrounded by a cosmos that operates according to principles of breathtaking elegance and profound mystery. The universe doesn't just have a speed limit, it has a wisdom, a deep intelligence that manifests in the perfect balance between order and possibility, between structure and freedom. You are part of that wisdom, a conscious expression of the universe's capacity for self-awareness, for wonder, for the kind of understanding that bridges the gap between the physical and the meaningful. The cosmic speed limit didn't limit the universe's potential for beauty. It enabled it. And you, in this quiet moment of transition between waking and sleeping, embody that beauty in all its conscious, questioning, dreaming glory. Sweet dreams, cosmic traveler. May your sleep be filled with the gentle rhythms of a universe that knows exactly how fast to unfold its infinite story. The speed of light will keep its faithful watch while you rest, ensuring that cause follows effect, that time flows forward, that the cosmos continues its patient computation of reality itself. And when you wake, the same fundamental laws will still be there, still governing the dance of matter and energy, still enabling the miracle of consciousness in a universe that has learned to contemplate its own magnificent existence. Until then, drift peacefully in the knowledge that you are part of something vast and beautiful, something that operates according to principles both simple and profound, something that has a speed limit not to constrain wonder, but to make wonder possible. The universe is still computing itself into existence, one moment at a time, at exactly the speed of light. And you, dear dreamer, are one of its most extraordinary calculations.